reply to the...
No, I just had printer issues. I emailed it to you, but I didn't actually print out a hard copy.
Printing is free here now.
What?
Printing's free down in the core. You just go and print. It prints it for free.
Yeah, I think you only
I know that.
That's how it's like.
That's what happens after that. Do you have to go to the harder? I mean, I
You
have to after that
start. You have to put money on your
account. Or,
yeah.
Is it
Your
always
$10.
free now?
it's like it's get 50
No,
copies.
they don't have, there's no such thing as some.
Yeah, they don't have SIM cards anymore.
Really?
You have
Some
IDs.
dollars have been phased out.
So you must have an account that you.
Yeah, they just like card.
Well, I once you speak, they go do, but they can't even.
I just did, yeah. Everybody's assignments. Okay, let's get started. Okay, let's talk about the article. So as you were reading the article and summarizing, let's just share your thoughts about what that was about. Is it Eric?
Yeah. It really upset me because I just learned, I was telling Joel about this, that I learned I was taught procedural pretty much my whole high school career.
Okay.
Versus conceptual. Conceptual is obviously touched upon within the topics, but I was kind of like, I was taught procedural, and it kind of makes sense now when I come to college.
Okay.
It's very conceptual, and I kind of like struggle with it.
Okay.
So.
Brianna?
I was actually the opposite. I was always taught conceptual. I went to like a small, like liberal arts-based high school, and that's like how they taught. So when I read the first one, I was like, what on earth is this teacher doing?
Okay. So that was unfamiliar to you?
It was unfamiliar. Yeah, I've never been.
I'm guessing that was not the experience of most of you. Okay, so others? So immediately we're talking about this difference between conceptual and calculational or procedural teaching. So can we be more specific?
Well, when I started algebra in 8th grade, I remember it's a new subject. I remember being confused because my brain would ask why, and they didn't have an answer for me. So I stopped asking why, and I learned just to follow the pattern, and then I understood why. But that's totally what this is against. Is you need to teach them why, and not teach patterns that let them gather their own.
Okay. Other reactions when you were reading? Comparing the teachers.
It sounded like the second teacher knew more about what's going on.
Okay.
But they had more input than the first teacher.
So what do you mean by that? They had more input?
Like I feel like he or she, they were like helping the students like figure out the problem, but the first teacher just kind of was like, okay, what'd you do?
Okay.
And then like, oh, I don't know what you mean by that, and then moved on.
Okay, so helping the students versus figuring out.
Yeah.
So tell me your name again.
Jocelyn.
Jocelyn.
One of the things I liked was that the second teacher kind of had everything, even though they would talk to individual students, it all progressed as like the class all together. Like, does everybody understand this part? And then they moved on. Whereas the first teacher just like, what did you think? And then what did you think? Like, it was all individual and then full thing rather than just going through the full progression. And I think that kind of makes a big difference.
Okay, so part of what you're saying, what I'm hearing is that conceptual teaching is about having the class as a whole, as a team, rather than a bunch of individuals.
Right.
Okay, Ashley?
I was going to say, I think the second teacher seemed better equipped to deal with when students had questions. Like the first teacher, with some of the students' questions, she was kind of more dismissive because she's like, well, you just did it wrong. You just need to do it this way, like this student did it. Whereas the second teacher made the student that like had a different answer explain step by step the how and the why of what they did, so that way everyone could see either another way of looking at it or they could figure out like where they went wrong, you know, a little better. Okay,
so, and maybe what you're saying is that effective conceptual teaching requires understanding of the teacher.
Mm-hmm.
So I heard you say there.
And I was like, at the end of, towards the middle end of the article, I was talking about how a conceptual teacher really needs to take the time to like, I don't really want to say research what they're going to be teaching, but like, teachers teaching calculationally or whatever, they kind of just have a pattern and they stick to it. Like I noticed when I student taught and interned a lot, the teachers had like their notes and stuff from last year, and they never really upgraded it to what was happening this semester. They never like renewed what they were doing. They stuck with their pattern and they never really changed it. And I figured that conceptually, it takes a lot more time, but I think it's more worthwhile for students because you're like, upgrading is not the right word, but you're changing it to fit them every semester instead of fitting the older students from before.
Okay, let's talk about that. So she's talking about having a pattern that you know you're going to follow versus what? Flexibility?
Like informing or like changing.
So what is that flexibility about? So if you had a different thought. What's that?
It's about the student.
Okay, say more.
What she's saying is that the teacher taught the lessons, and the lessons remain the same no matter what the students might have functioned in that lesson. It didn't matter. That's what the lesson was. Whereas the students, they have different avenues that they can follow and learn, and they can all learn together independently. Well, I can't think of the word. But yeah.
Yeah, no, that's
dynamically.
Excellent.
There's dynamics.
Excellent point. So teaching conceptually isn't just about what you're teaching. It's about knowing your students and listening to their thinking. So that's why we have to be. You can't always depend on this pattern from A to Z that's going to work perfectly, right? We have to listen to our students. We have to ask them and listen to what they're thinking, and also know what their attitudes are, right? And know what their history is coming in. So teaching conceptually is not just about what you're teaching, but it's about teaching your students, knowing your students. Eric.
Yeah, to piggyback what both of you said, the key word that she said was time, and you feel in the conceptual one that teacher allowed time for him to make those, or was it she? I think it was a she, to make those decisions, to listen to the students and figure out where they're coming from, versus the first one, which seemed very rushed, even within the conversation. So when you talk about learning more about your students, you need to set aside some time so that way within your curriculum you have flexibility, because when you write a lesson plan, you're not like going to be right to the T 40 minutes nonstop. You have to have that time for buffer for questions and conversation.
Okay, and so let's take a little tangent here. So there's a huge push, not push, but there is a huge current now pulling us towards more and more online classes. How does that?
There's no one there.
So how does teaching online, relate to what we're talking about here? So someone new. What was your name again? Brianna.
I think teaching online would mostly fall on the calculational aspect because they're just, like math-wise, you just have problems that you're constantly doing, like on homework or on all the math programs online that are there, unless the teacher has like actual verbal messages of lessons, it's going to be mostly calculation.
Okay. So what's harder, or if not impossible, with online courses?
I've taken one math class online.
Okay.
I hated it.
Okay.
Because you just get these structured videos, and you can't just ask a question, you just rewind it and look, do I understand it any better? No, not really. There's no flexibility. There's no room for any other kind of alternate explanations when you're going through these things.
Okay. Ashley.
I'd say the same thing. I'm taking an online math class right now, and part of it that makes it like so hard is that there's no discussion. It's like there's videos to watch, but you can't like interact with anyone. And if you do, it's like you write an email, you wait for a response, and you do it back. So it's not the same as like sitting in a classroom having a class discussion or working with someone next to you on problems and stuff and figuring out like ideas and stuff.
She talked about interaction. So is the interaction important, and why?
You have to be able to get ideas from other students.
Okay.
Being able to get it quickly is better than having to do the emails. But also there are online ones where they have set times in which they all get together and they talk about it. My boyfriend has that type of class, where when it comes to the math classes, they make sure that they make time to have everybody get together at one time.
So what about, so think about now you're facilitating an online course, and you want to be an effective teacher.
You have to figure out everybody else's schedule.
How,
It's hard.
how does it hinder you? It's on there.
I would think that an individual thinking would be really important for learning math, because that is just my experience, that when I'm learning or when I'm solving a problem, during my thinking process, I kind of like take back, don't want to share with another person, because I'm just in my own world trying to construct like what I'm supposed to do. I think that would really help me a lot with critical thinking and mathematical understanding. That'd be better help for me. That's just my experience.
Comments about being teaching aspect of an online course.
Well, a lot of online courses will have tutoring labs as well.
Okay.
And that's where they can you have to train the tutors to be able to interact as well. So that most online courses that I've seen will have tutoring hours that they go. Another aspect off the subject on the two teachers is when he made the fraction a whole number, just because the number itself didn't matter, it was the concept. That's huge. Whereas the other teacher says, oh, it's a fraction, don't be afraid it's a number, it's just a number. The fact that fraction's a number and it didn't matter what the number was really big paradigm shift for a math teacher.
Right, because the
the
traditional way is the answer and the value is everything, right?
Yeah.
Getting that number. So, so it's I find it, students are very uncomfortable when I'll write a final answer like this. That's the final answer. Why? Because we had 24 units of one quantity, and to get the amount of the other quantity, you had to multiply by 37. So then this is the corresponding amount of the other quantity to the 24, or something like that. And this is very uncomfortable. This is very uncomfortable to students when it's not about the final answer, but about the meaning and the process. Tell me your name.
Morgan.
Morgan.
That definitely shows like a jump forward in like technology, where schools trying to catch up with it, because everyone has a calculator on them. You have your phone,
Right.
so you can do calculations very easily, anytime, whenever,
Right.
wherever. So it isn't important anymore. It's important about how you got there and what it took to get there.
Yeah. So the users of math today are not human calculators. They used to be. But now we have Wolfram Alpha. It's a great resource.
Yes.
It does far more than you could do in a split second, right? It would take you 10 minutes to come up with all the different results that they come up with on just one question. And it just comes out, in a second. Graphing calculator, incredibly powerful and can do things really well. So the math users of math today are managers. They're deciding how to use these different resources, and how are we gonna program the computer? What are we gonna put into Wolfram Alpha? How are we gonna write the command lines on graphing calculator to do something powerful that we need to do? So that requires great understanding, right? Jocelyn.
I'm thinking for like an online math class, if you wanted it to be more than just a procedural lecture or
Okay.
a one-way thing, if you want it to be interactive, you're going to have to incorporate a lot of like online programs or online games that are specifically engineered for educational purposes. And I've seen some, but they tended to be for a lower level than high school. It tended to be for like 6 through 8 or something. But I'm thinking if there is this big push towards online school, I'm pretty sure that it's not going to be something that's just going to, miss math. And for teachers to be able to accommodate for that, the only way I can think of doing that is by having an electronic program that can kind of go through those same steps and kind of, where you answer something and then it will respond back and have it be an interactive program rather than you're sitting and inputting an answer and it's just telling you that you're wrong.
Okay.
But I'm not sure how else we can do it.
What about the expectations of the contrast of expectations of each teacher and then the implications for students in the long run with teachers of or not conflicting, but different expectations, maybe like teacher 1 and teacher 2. Did you see a difference in expectations of the students, or of the teachers, excuse me? And Eric?
I felt like the first one was kind of teaching more towards like a standardized testing. I know I wrote that down in my paper. It kind of felt like the first teacher's focus was kind of more, let's just get the right answer because you guys are going to apply this somehow, versus the second one, like we talked about, was trying to understand the students and understand where they were coming from, and thinking, second teacher was kind of planning for long-term conceptual learning, the first teacher was kind of like, for the, let's get the quick, easy answer so we can move on. So that's kind of how I felt that was.
Christopher?
Another thing that I noticed too, based off of that, was that the students in for the second teacher were not as well. The teacher created an atmosphere such that the students were not afraid to be wrong, you know. And that's the one thing that I've seen in classrooms where teachers who are procedural oriented, they teach the procedure. They're like the final answer is the most important thing, and students are scared to death to be wrong as to whether or not it's the right or wrong answer. Whereas the other teacher was just more like, what are we doing here? Come on, let's go back to step 1, let's go back. And I loved how he stopped, or she stopped, the one student who did like the 6 calculations in a row, and he's like, whoa, 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 stop. You just went too fast. Start over again. What did you do? You know, that kind of thing. And just making them critically think about what they're saying.
Yeah, and we have to hear what they're thinking so we can help them improve their thinking. You see? This is something that's going to be very, very challenging with online courses. So when there's a problem, it's the difference between, okay, what do you do first? And when you read this, what does it say to you? Right? So what do you do first? Immediately, that's a right or wrong answer. Are you doing the right thing first or the wrong thing first? The other way is, so what does this say to you? What does this mean to you? Well, there's no right or wrong answer. If they're honest, they'll tell you what it means to you, right? And that's what we want. We want to know what they're thinking so that we can help them shape their thinking to good understanding. And that's going to be a great challenge of online courses. Why are most NHL players, hockey players, born in January, February, and March?
What?
Did you know that?
No.
There's a great weight of all NHL players. Many, many, many of them, the great majority of them, are born in January through March.
Doesn't that have to do with the age deadline so that they'd be the oldest they could possibly be without passing the deadline so that they'd be further physically developed and
Okay.
advanced so that they'd have a physical advantage over somebody who is, say, a year younger than them but still, or 11 months younger than them?
Yeah. Michael, were you going to say something?
Oh, no.
Yeah, Marty.
It's because that's when they would get stuff to play hockey for their birthday. And they got
Because it's Leonard's not
So are people that are born in February or January more genetically or just have a more natural ability to play hockey than those born in November or December? So what's going on? I think Jocelyn's onto something here. So what is it? Why do they end up being the experts or the ones who make this their career?
They have like an 11th-month advantage over the other player.
Okay, so when they're 20? When they're 15?
I was thinking it's because since they're born in January, by the time December comes with winter, then they can kind of train. They're already almost a year old, almost 2 years old. Compared to people who are born in October, they have to wait an entire year. It's almost like they can get that extra training in when they're younger.
Okay. Other ideas? Michael?
It's probably like growing up. So I know for club soccer, there's like a certain deadline where if you're born like for soccer it was after August, probably something different. But like if you're born after August, then you have to play like a year down. So there will be people who are like almost a full year older. Like I know I was like a full year older than my friend Kevin who was on the team, and so you know I wasn't exactly physically developed, so we're pretty small guys, but. I'd imagine for some people who are more physically developed, that'd be a pretty strong advantage to be that much stronger, like going through your youth and to just be able to develop more quickly.
Okay, so let me kind of, you all are touching on some of the reason why, but there's a whole aspect of this that you're missing. And it's Frank, you want to try?
Yeah. I was going to say because, like the playoffs and Stanley Cup time is during late spring, early summer. So maybe the parents are huge hockey fans, and they conceive their child after their favorite team. And 9 months later, in January, February, March, that's baby popped out.
Yes.
No better aphrodisiac than hockey.
Going back to them being more developed, they feel more proficient at it because they're doing better at a younger age, and so that habit stays with them to keep it with it, and that trend of being better at it makes them want to make it a career.
Okay, so it has everything to do with their parents and coaches. What happens? So if you take the 5-year-olds, who's gonna get picked for the All-Star game in the 5-year-old hockey leagues? The ones who are born in January and February, they're going to be a little bit stronger, a little bit faster, a little bit more experienced. Well, not necessarily more experienced, but a little bit stronger and faster. Their bodies will be a little bit. And so then what happens?
Then they get the experience.
Well, yeah. Because why? Because the coaches pick them. The coaches pick them. The coaches pick the ones that are a little bit faster, a little bit stronger, a little bit taller. They get picked. And so when that happens through, Little League hockey, then the anticipation of the adults on these kids is that these ones will be good, these ones won't be as good. So what's the outcome?
Exactly what they thought it was.
Yeah, so they're creating this environment, and it was unconscious, of course it was, but this environment is created where the expectation, the anticipation, ends up being the reality, and that was not based on natural ability of the kids, but it was based on selection. So how does that have to? What does that have to do with teaching?
You just pick out the ones that we think are going to be good. We have to help everyone.
Okay.
The attitude of the teacher helps influence the kids. If you walk in with a positive attitude thinking that everyone can strive to be great, the kids can recognize that versus when you walk in saying, all right, right or wrong answers through grade. Kids set up, like they said in the article, they set up low expectations for themselves where they see in a procedural classroom, like, well, Timmy got more points than me, he must be better at math than me. And it's like, well, if I can't understand the concept, then I guess I'm bad at math. And they literally word for word said that for the kid. It's just like, math doesn't make sense to me. He made something up in his head that might not even been true. And the same with the hockey. It's like they make these minds of these all-star kids are better than them when really it might not be.
What's the attitude of an intermediate algebra teacher versus an honors pre-algebra teacher? Think there's a different expectation and attitude there? Frank, were you going to say something else?
I was just going to say, like, if the teacher picks the good students and teaches towards them and gives them, conceptually based questioning, then those students are going to grow.
That's right.
And then the students that struggle, they're like, well, they'll never get it, so I'm just going to give them the procedure. Step 1, 2, 3.
Did you hear what he said?
Well,
This is the point. Yeah.
I don't.
Yeah. Jocelyn.
There's been a lot of stories. One that I heard from an old teacher was that she really wanted to know, this is when she was much younger, but she really wanted to know how her students did on their IQ tests. And the principal said, no, we can't let you know that. You need to treat the students, independently of that and all that. And she snuck into the office one day and found a sheet with all their names and a whole bunch of numbers, and they were all really high. So she thought that they were all very, very smart, and she, designed her class, thinking that they were all these extremely intelligent students, and they performed extremely well in class. Well, at the end of the year, she found out that they were actually their locker numbers, and not their IQ scores. But just thinking that they were really that smart completely changed how they looked done.
Yeah, it's absolutely a fact. There was a research study where they had reading groups, right? And the researchers, they had the two groups. They had the lower group and the higher group, and that's what they told the teachers. So this is the lower level ability readers, and these are the higher level ability readers. But the reality was they were the same. The groups, the ability levels were the same of both. But the teachers had this perception. So what did they do? The teachers, the way they treated the higher level students, they gave them more critical thinking, more challenging readings, and then the lower levels it was more like word definitions and easier vocabulary. And so what do you think the outcomes of these two groups were in 2 years? Or 2 years. I mean, it was striking how the one group excelled, the other group was way behind, but their abilities were the same. It was all about the teacher's anticipation of what they could do, and that meant everything.
And on that same note, the difference, they'll say is that the teacher had a group of, he called them the elite students and the smart ones. Another group they called the really hard worker ones. And the really hard worker ones end up actually doing better because they persevered more than the elite ones who it was past their understanding that they didn't try. But so again, the mindset of the teacher and what you portray to the students is a huge effect.
Sorry. With the conceptual lesson, the vignette, I felt I understood the problem better though. So under the thought, the school of thought where you just want to teach the kids the procedure, I didn't get the first lesson. I had to read that part a couple times. So I'm like, what are they trying to say here? But when they actually broke it down and explained it and took time to discuss it, I'm like, oh, I totally get this problem now. This completely makes sense. So I think that's a really bad school of thought that, well, these kids are not going to get it. We're just going to, because when you in turn break it down more, they understand it better, regardless of skill level.
Students can understand the whys and the hows and the things behind the math that we're teaching them. So what is the obstacle then? What is that? If they can, what are they bringing into the classroom from their past experiences that's going to be the obstacle if they can do it? Yeah.
Well, one thing that I feel like was like in the first teaching example, there was a kid who said that he didn't get it, and then when the teacher tried to explain it to him, he still didn't get it, and then the teacher just passed over that student. And I feel like there are issues that students have that are not addressed early on, and then as they continue to not be addressed again and again and again, then it just leads to things like, well, I just don't like math anymore kind of thing. And I love how the second teacher was like, when someone didn't understand, he's like, okay, let's talk about that. Let's talk about why you don't agree with this person, or, and that kind of thing. And it was just great teaching all the way around the second one.
Ashley?
One of the challenges that I noticed, like in my last internship, was when I would try to when I was doing lessons and try to ask the kids, okay, so what does this mean, the how and the why, they get distracted even when you're asking them because they're so conditioned to think of all they're trying to see is the numbers. And you ask them something and they just keep spewing numbers at you, and you keep asking the how, why, and what, and it's just hard for them to break from what they're used to, which is finding the numbers and telling you how you solve it. So that, I think, was the hard part about trying to implement the conceptual.
Yeah, so when you have your classroom, if you're gonna go for it, it's gonna, it takes time to turn the Titanic around, right? The students they've been trained semester in and semester out that's the culture. That's what a math class is, right?
I was gonna say, I think it also becomes a matter of time. Like, a class period is only so long, and you can only spend so much time trying to use conceptual learning, because students are used to here's the format, plug these numbers in, and you'll get the answer. Whereas if you want to teach them what it means and what it's all about, it's going to take a lot longer to get through one problem, and then they're just going to, I don't know, I feel like students could get distracted that way, like she said, and just become disinterested because you won't just give them the answer you're actually trying to pull out of them.
Yeah, they're not used to thinking for long periods of time. True. It's really true. If you're stuck, then the teacher comes and rescues you, and kind of tells you just what's next, how to get unstuck, rather than, okay, tell me what you're thinking. Let's look at the situation. What does this all have to do with our course? Why are we talking about this in our course? Technology and visualization. Somebody new. Melissa, any thoughts?
I think it just
comment on other things that were being
Oh,
said.
great. Okay.
But like kind of like they were saying how it is a distraction in classrooms. I know like my last internship teacher said the exact same thing whenever I brought up like, oh, how about doing like conceptual, like try to implement that in your classroom, and she always said like, oh, they just don't respond to it. But I just feel like, was there like a phrase saying like it only takes 10 days to break a habit or like to form a habit? If you can just struggle for those 10 days and keep pushing and seeing they can form a habit of thinking more critically, imagine like all the benefit they would have in the long run. Whereas just like, oh, I can't do this, they won't respond, just keep trying and trying.
So the teacher's attitude, her belief was, the students can't learn that way. So therefore, she's right. Do you see? As long as that's her attitude, she's right. They won't learn that way because that's how she's going to teach, and that's what she's going to project. That's talking about the. Just one or two more.
I had another teacher who was really concerned. Well, I can't get through as many problems. I can't show them as many examples because it is so time consuming. But it would seem to me if you taught them that understanding really thoroughly for one problem, they could get other problems that you wouldn't even have to show, like, if it's just minor twists, you don't have to show them every single kind of problem. They'll be able to because they have the understanding to figure it out for themselves.
That is the goal, problem solving. It's not that they can replicate examples, but they can come to a new situation and they can actually make some headway just with the tools that they have, rather than having to have an example and replicate it. Yeah, you hit the nail on the head. One more.
Well, I was going to say, like what this has to do with the course
Yeah.
is, in the article it said that, like, one of the reasons why it's really hard for teachers to stick to more conceptual teaching is because you have to, it basically requires you to drop the textbook and basically come up with your own problems and examples, and I think having a good understanding of like what programs and stuff are out there to help you basically create your own set of problems that you're going to use, as opposed to like, you know, having a book that just has ones that you have to follow through.
Yeah.
Give you resources.
Yeah. So exactly. So I have something in the next 15 minutes that I have a conversation that I want us to have, and a set of ideas that I want you to think about. Okay. And so what I've done to generate that conversation is I've created something visual. Okay. So let's start that. So here's what I want you to get out a piece of paper and a pen. It's like a quiz. Pencil's fine. But when the visual representation freezes on the screen, it makes it hard. Oh boy. Oh, there we go. Let's see if I can try this again. Okay. Oh, no wonder. Here's what you're answering. Everyone's by themselves. Just give me a second. Three questions. Three questions. Everyone's answering by themselves. What's the meaning of the radian measure of an angle? What are the coordinates of the point on the unit circle associated with theta equals 2.5 radians? A is an estimate. B, exactly. No calculators, no computers. What does it mean to represent a curve or surface parametrically? Okay, take a couple notes. someone else coming in? Late. You are? Yeah. Okay. So, even if you didn't finish, it's okay. Something to think about to get us started. Okay, I'm showing 3 circles. Okay, we can just call them small, medium, large. Okay. Let's do one a little bit back. It's saying off. I don't want to push it, but it says off. Okay, so what am I representing? Nothing. There we go. What am I representing here? Amanda? Of what? Right, okay, so what I'm going to do is I'm going to take that radius and I'm going to wrap it on the circle. Did you see that? Do it again. I'm going to take that radius and I'm just going to wrap it up on the circle. So here's that radius of that small circle. Actually has a radius of 1, and I'm going to wrap it up on the circle. Okay? Would you agree that that would determine an angle with this initial side and this terminal side? Do you agree with that? That there's a unique angle whose vertex at the center of that circle has the initial side at the start of the arc and the, okay? So, oh man, what happened? Okay, we're back. So we're going to call that angle 1 because it's 1 radius length. It's 1 radian. Somebody new. Terlina, what am I representing there? With the blue segment. Okay, the radius of the middle circle. What is the radius of the middle circle? 4. Okay, so I'm going to do the same thing. I'm going to flip that 4 up on there. And then what am I representing here? Chrissy, what is it? Radius of the big circle. I'm going to flip it up just like the others. Move this down a bit. Okay. What about the angle? Is the angle all the same? Andrea, you talk about that? What's the length of the blue arc? What's the arc length of the blue arc, James?
What is the arc length?
Yeah.
1 radius.
1 radius length. Isn't it 4? It's not 4? 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 . 4 The length of the blue arc isn't 4.
Yeah.
It is 4. Is it 4 or not?
Yes.
No, it's in radians. Arc lengths are in radians.
Arc lengths are in radians. Joel, weigh in. How long is the blue arc?
It's, I would say 4. So that this is the radians. Radians is a measure of an angle.
Okay.
It's still 1 radian.
It's still 1 radian. Somebody else?
The length of the arc has to do with the actual radius as well.
Okay.
And it's a factor, it's a multiple. So if the radius is 4, the arc will affect the length of the arc.
Okay.
I thought that didn't have to do with where it's the x-axis because they're all proportional just based on the size of the circle.
Okay.
So it's just going to be still one radius length, depending on how big or how small the circle is.
So is it 1 radius length or is it 4?
4 units.
4
1
ones.
radius.
4 units, 1 radius.
What's that?
Like they all said that at the same time. I said 1 radius length, but 4 units.
Both?
Yes.
Blue one, yes.
Matt?
So
Simon?
the blue circle, for the middle circle,
Okay.
the blue line, that's absolutely true. It is equal to 1 radius length, which
Okay.
is 4 units long. That blue arc is 4. The purple and the red one, that's not true. Well, the 4 isn't true.
Okay. What is a radian? Do these all show the same angle? They all show the same angle, 1 radian. Are those arc lengths the same? What's that?
Comparatively to that circle, yeah.
Comparatively to the circle they are. As lengths, they're different. But as relative length, they're the same. Relative to the radius. Okay? So that's what a radian is. A radian is a relative length. So yes, this is 1, 4, and 6. But as relative lengths, how many radius lengths is that? What's the relative length of that? This one. 1. So therefore, the angle is 1 radian because it's the arc length in units of radius lengths. Okay, so let's zoom in on the unit circle. What am I representing there? Jorge. Okay. And so therefore the angle is? Mario, what's the angle?
1 radian.
1 radian, okay? What does the length of the relative length of the purple arc represent? The angle of 2 radians. Okay? Estimate the x and y coordinates of the angle corresponding to 2.5 radians. This is estimate, question 2a. Brianna, corn. Can you estimate the x and y coordinates? I don't know, can you see it well enough?
It looks like 0.9 something and negative 0.3.
0.9 is that, so x is 0.9 and y is negative 0.3?
Yeah.
Alana, for 2.5 radians, estimate the coordinates of the point on the, do you agree with her? She said 0.9 and negative 0.3. Okay, it has to do with the sine and cosine. You want to try again?
Yeah.
Go ahead.
I'm gonna say negative.
Here we go. It's coming on.
Negative 1 and 0.5.
Negative 1 and 0.5. Sarah, agree with that?
I was gonna go with like a negative 0.75 and like a 0.5 or something like that.
Negative 0.75 and 0.5. So when I say that the point, or the coordinates of the point correspond to 2.5 radians, can you just come up and point at what you're looking at there? So,
2.5 radian.
yeah, so the point in question.
It's about here.
What do you think? Agree with that?
Can you, I don't know if you reach that height here.
Okay. All right. What about the exact coordinates of that point? Right.
Cosine 2.5, sine 2.5.
Cosine 2.5, sine 2.5. Okay? Any questions about, so that's questions 1 and 2. Any comments, observations? Okay, so was my visual progression, was it helpful in the conversation? Okay, so yeah, so I had some idea of what kind of ideas I wanted you to either solidify or learn for the first time, and so I just in the last couple of days I developed this kind of progression of using the visual to aid in that conversation. Okay, what does it mean to represent this, say the unit circle or any curve parametrically? What do you think about that? Eric, any ideas? What does it mean to represent a curve parametrically? Okay. Yeah.
The coordinates of each point on the plane in space are given as a function of parameter.
Okay. All right.
The ordered pairs change according to another variable, which is usually t.
Yeah. Right. Yeah. So.
Or you're using the angle to represent the relationship between the circumference.
So the angle. So if we're talking about this particular curve as writing that curve parametrically, the angle would be what? Represent what? Joel?
It's just using equations in conjunction to map out a graph. Because you can do like x, y with the typical with t, or you can say one equation is for angle and the other equation is for distance from polar coordinates.
Okay. Okay. So yeah, you're all talking about pretty much all got it. So it's about a way of graphing the curve point by point as ordered pairs, as x, y ordered pairs. Okay. So what are we telling graphing calculator if we have a command line with x and or y in it? Remember what we talked about last time? If a command line has an X and or a Y in it, what is graphing calculator going to do? Graph. It's going to graph. X is reserved for the x-axis. You can't use it as a parameter to just represent a value. Y always represents the y-axis. Okay? So we are starting a command line that's going to tell it to graph. And so this represents an ordered pair. Okay? So I want to parametrically represent that unit circle. Okay? So what do I want? I want every ordered pair, x and y, on the unit circle. What will it be? The question is, oh, darn it. There we go. What's that? So what goes here so that we represent every ordered pair on the unit circle? What's that?
Cosine and sine?
Cosine and sine.
Is it R?
Is it cosine and sine?
Oh, I thought you were
What do you think?
Yes.
Yes. Thank you.
I like it.
Cosine of what?
Some parameter.
Some parameter that's going in this case going to represent what?
It'll represent the angle.
It represents the angle, right? So in graphing calculator, t is reserved for the parameter, okay, that will generate a curve. That's what t is reserved for. Again, t, you can't use t to just be a fixed parameter. You know, you can't say t equals 3 and then use t in some formula. It always will mean the parameter in parametric equations, so it will take on a range of values one at a time. Okay, it will take on a range of values one at a time. So if we hit graph here, and if you look over here, it says the range of t is from 0 to 1. What do you see and why? So we can explain. Why are we seeing what we see? Why aren't we seeing the whole circle, and why are we seeing what we are seeing? Jason?
Wouldn't the cosine t sine t, wouldn't that just be 1 radian? Anyways, and that's what it's showing.
So
Well,
t is taking on a range of values. T takes on a range of values. In this case, that range from 0 to 1. So let's think about when t equals 0. What will happen when t equals 0? The 0.10. Why? So when t equals 0, it's going to give us the point 1, 0. Now we're going to increase t a little bit. What's going to happen next? So t is 0.05. Okay, sine's a little bit bigger than 0, and?
So that's why it's
Increasing? What about cosine? A little bit less than 1. So we're going to get another point. So so just think about this starting at 0, giving us a point at 0, then increase t a little bit. It's going to give us another point. And it's going to keep doing that until it reaches 1, and then instead of actually drawing dots, it's going to plot the points as a curve. Okay? So why didn't we get the whole unit circle? Alexis?
And you didn't specify it to start or stop any place. Why does it just chose variable? So unless you tell it to go like 0 to 2i, it's not going to go anywhere.
Okay, yeah, the default is 0 to 1, but it's also 0 to 1 is also very convenient to always use 0 to 1. So, I think, so why do we get just that portion of the circle? Why not 3/4 of the way around, or why not up to the top of the circle?
It's showing 0 to 1 radians, and that's like 1 radian.
Yeah. So remember, t in this case is our radians, and so that is every t value from 0 to 1 radian and the point on the unit circle. So how can we show the whole circle?
I think with one light before.
2 pi.
What 2 pi?
Oh, you can make t go to the 1, change it to 2 pi.
Okay, so you can go over and select here 2 pi. Okay, easy enough. But I want to keep it from 0 to 1, and I want the whole circle. How am I going to do it? Talk to the person next to you. So I want to see the whole circle, but I want to keep my t going from 0 to 1. Figure it out. You got it?
I'm gonna look and see if I can.
You could try going to the website and specific site, see if they have customers online, and then just say, you use the new I'll show you. Yeah, I'm sorry. To get the vector, you guys grab Calculator open. You're welcome to do that. To get a 2 vector like that, or a ordered pair, it's Control 2. Control 2.
Oh, there it is. 2 vector. Yeah. Okay.
The thing that I just did with the radians and stuff?
The original one. We had the slide.
No, because you're going to make stuff like that. So you're going to get to make stuff like that. So I don't want to. I want to teach you the software so that you can go through that process of figuring that kind of stuff out. Okay, so lots of you are getting it. What do we need? We want t to go through from 0 to 1, but we need that to go, as t goes from 0 to 1, we need that input to go from 0 to 2 pi. So how can we do that? Okay, is it a circle?
Yep.
How about now?
Yeah.
That's a circle. Yeah.
Your way.
How do you know it's a circle? So mathematically, so discuss your tables. Mathematically, how do you know that that's a circle? Mathematically. Prove.
Radius.
So how do you know that? You know it's a radius.
Both sides are radius of 1, and then you can take each of the right and move the other. 1 is like the negative 5. Estimate.
Center on the bottom. One does horizontal and then it's shift.
That's it. Okay, so your ideas. So, mathematically, how do you know that that is a circle? So, convincing argument. Anyone want to offer up convincing proof?
Radius is the same all the way around.
Okay, so she said the radius is the same all the way around. And so I said, sure doesn't look like it. How do you know? How do you know that?
Well, it intersects the 1 at the 1, 1, negative 1, 1.
Okay. So because it intersects, what's happening? It intersects at these 4 points. Therefore, it's a circle.
That's
Jocelyn.
what I thought at first, but then I remembered like if you have a rectangle or square with rounded edges, it'll be skewed, so it's not a perfect circle, but it would still go through the same point.
So what is something else that you could describe easily that goes to these 4 points? Is it a circle? Simon?
Or something different is that you can just use 3 points to locate the circle to verify that it is a circle. Not 4 points, just 3.
So does this verify that it's a circle? So that what I hear you saying is we've got more than enough.
Yeah.
So it is a circle because these 4 points are 1 away from the center.
Not those points, but it's
Every
like, yeah, like if you find any 3 points, I mean, if the circle goes to the 3 points.
Well, they also have to have like supplementary angles, or you have to have right angles or something like that.
We want a convincing argument that this is a circle because it sure doesn't look like a circle, right? How can you, Ashley?
Well, I guess like the easiest way is like the diamond. I guess it's divided into 4 pieces with the axis there,
Okay.
and all of those pieces are the same. So those are all like the same distances there. They're the same like distance from point to point.
Okay, with the diamond, what I was trying to show with the diamond is that the argument was not convincing that it was a circle. You see, that was the point of the diamond. That I came up with something that fit, and I don't mean to pick on you at all, but I fit something to what she used as the argument that's not a circle. So therefore the argument fails. Do you see that? So this is what's called a monster. Okay, a monster is something that you claim is proof or a convincing argument, but you can show something that fits that criteria, but then is not what we need it to be, right? So that was the point of the diamond. So
if you chose any point and made a right triangle with the
any point, okay?
x-axis, and then just showed that the Pythagorean that radius was still 1.
Marnie's offering up this. Choose any point. Pythagorean theorem, which we could show for that point that r equals 1. What do you think? Convincing argument?
That's kind of where I was headed. Like if you picked any points on that circle, and they all have the same radius, that would make it a circle, wouldn't it?
But it's still your generality. How do you generality?
Yeah, so the conclusion has to be that the radius is 1, right?
Yeah.
So yes, if you can conclude, given a point, that the radius is 1 for any point on the circle, or any point on the curve, then it is a circle.
Yeah.
So is this convincing that r is equal to 1 everywhere?
You'd have to check everywhere.
What are the coordinates of that point right there? For every point.
That would be a point.
No, it's true.
What are the coordinates of that point? Generalized, any point. Yeah.
So basically, you take the square root of x squared plus y squared, you've always got 1.
Okay.
So that's how you prove that
Right.
no matter what the value of t is, you've always got 1.
That's right. That's right. No matter what t is, square root of the sum of the squares is 1. Because what is this right here for any point? It's x. Or? Cosine. Christopher? What is that? Cosine t. And what's that? Sine t.
And then therefore cosine squared of t plus sine squared t is equal to 1.
Cosine squared t plus sine squared t is always equal to 1. And so for any point that you pick, you're a distance of 1 away from the origin. Therefore, it's a circle. Okay, one last thing to think about. So the actual equation of ellipse is x squared over a squared that's the xy equation of an ellipse. So can I use
Okay, yeah, look at that.
parametrically?
Well, you're 1, you have 1 over x squared over 1, b squared over 1, and that would be x squared plus y squared equals 1.
Oh, I was changing gears, sorry.
Oh,
Okay.
Yeah, I was
but
changing
that,
gears.
you could use that though as well here on this
Because a circle is a specific type of ellipse.
your A and B are both 1.
Okay, so the question is, can we represent an ellipse parametrically? So we're done with this.
Erases the lines.
It erases everything. It puts white over the top of it. Okay, so,
Oh, you're painting.
all right. I don't want to write this down. Okay, so this is a circle. So I want to make it a circle again.
You're still on paint.
So the question is, we're still in a circle, but can I represent an ellipse parametrically? Can I represent an ellipse parametrically? How would you do that?
Put a non-1 or 0 coefficient in front of each cosine side.
Okay.
Or just
And then you know what I'm going to, so what do you want to do? Tell me.
2 is fine. That should do it.
And what am I going to ask? What am I going to ask?
Is that an ellipse?
How do you know, right? So it looks maybe like it's an ellipse, but so we threw a 2 in front of the cosine. It looks like it might be an ellipse. How do you know? Okay, so we'll leave it there. I'll post homework for Monday tonight.
Is that going to use the phone sound?
I'm sorry?
Is that going to use calculating the focus? We have to get C.
No.
And they make maybe 2 right triangles, make it very
Here.
It's still there.
I
I have a question. On the syllabus, I haven't seen any policies on late work. Do you accept late work?
You know, like at the beginning, yeah, but then, I mean, like a one-time deal at the beginning, and then after that.
Right, because I just didn't print out my, I don't even know how to pronounce it, the presses. So, would you rather
Can you just go print it out now?
I don't have it on file with me now. That's the thing, it's on a jump drive.
Okay.
Is there any way to, you don't want it emailed?
Well, I mean, that's what you're going to have to do, or you could, yeah, just email it to me tonight.
Okay. Thank you.
So I typed up the first one,
Okay.
and then the second one I hand wrote in the responses.
Okay.
Is that okay, or do you need it typed? Because the second one I didn't type because I ran out of time with the printer, and I was like, well, you wanted a hard copy.
So I said that the précis and the questions were hard copy in class, and then email me the graphing calculator assignment.
Right.
So
is it okay that for the answer to the questions I hand wrote it?
Oh yeah, sure.
In pen? Okay.
Yeah, sure.
Cool, because I was really
Yeah, it's just a hard. I just said hard copy.
Okay.
As long as it's legible.
As long
it's
as it's
fine.
legible. Okay. Cool. Thank you.
Okay.
I use because I live at Vista, and I use their printer in their business center. And it's broken right now. I didn't know Core had free printing. Do you want me to print out a copy and bring it to your office or something?
So you can just email. You can just
I
email
emailed
it.
it to you.
Oh, you did email it to me.
Yeah. I mean,
Oh, wait, this isn't.
Chris.